My name is Sascha Maennl. I'm heading the process automation verticals here in India, based with my family out of Mumbai. And I would like to give you some insights, some views about new processes and new technologies. Before I start with the same, let me position myself first a little bit in the organization. Siemens is a large organization. I don't want to talk about this. I'm belonging to the industry and here to the industry automation, where we are taking care for various process verticals, starting from chemical, pharma, food and beverage, glass and solar, water and wastewater. Today, if we are looking to the DCS market, we have to answer certain market requirements and challenges. First of all, let us look to the market situation. The urbanization means more and more people going into large cities, and the increase of lifetime are changing the demands and the requirements for the process automation. For example, if we're looking to the lifetime, the pharma industry is becoming more and more important. Dynamic consumers and market requirements means fast changing markets, fast requirements, and the environmental concerns definitely are changing the market very rapidly, and we have to give an answer to the following points. The challenges which you are facing as an end customer, the challenges which we are facing as a manufacturer, the increase of the productivity has to go on and on, the reduced cost, the total cost of ownership, the production efficiency, and the energy efficiency and sustainability. These all are the things which are influencing the day-to-day life and the day-to-day work from our side and your side. Looking now to the questions which the process industry have, the questions where you need answers, the questions where we would like to give answers from our side is, which saving potential can be offered over the lifetime of your plant? Which advantages are inherent to integrate architectures? I mean, it was spoke a lot about cloud computing, about integrating systems, interfacing. I would like to come to this point a little later. How to optimize production processes with adequate systems, which energy efficient potentials can be utilized, and how to manage potentials and leverage workforce excellence. Let us start at this point of time a small circle. The integrated engineering is, from our point of view, from my point of view, the key to the success at this point of time. Already when the first idea on your side starts, long before anybody starts thinking about a process control system, a lot of data is getting generated. We call this phase the plant design. So when the first idea for your products comes up, you're starting collecting and generating data, which should be stored at this point of time because they are required for the further steps of this whole process. Unfortunately, today, there are many tools used for all of these phases so that the data integrity and the data storage becomes a problem in today's world. If the plant is ready for the approval, the basic engineering starts. And here again, a lot of information, a lot of details are generated, and these details and these informations are again stored, in best case in the same tool, sometimes somewhere else. Now the plant is ready for the tendering. Means the documents are generated and the documents have to be submitted to the vendors and you get data back. So again, now data are coming in a kind of a detailed engineered phase. Here also the process control system becoming more and more into the picture. The plant is ready for installation. At this point of time, nearly all information are existing about this plant, and now really the fine-tuning can start. Alarm management, what kind of information has to be seen, which data is more important than other data, and very important, at the end of the day, after handing over this plant after the commissioning, the maintenance and operation. The situation today is that the data are stored in many systems and the data accuracy is not always granted. The point is here, if you just look to the maintenance and operation at the end of the commissioning, the plant has started, you need documentation which is as-built documentation. And the same moment, your expectation is when anybody of your maintenance and operation personnel is outside in the plant and faces a challenge, that he should understand immediately what was the original design behavior of this pump, motor, valve, whatever, and what is the situation at the moment. So the idea of the whole integrated engineering is to start at day one with collecting the data in the right formats, store the data at the right places, and integrate everything together. Looking to the timelines, how it was, let me say, a little bit in the past or partly today. Everything was in a kind of a serial mode. So you were starting with one tool, the product design itself of your product. On the other side, with another tool, you were starting the process design and the simulation of the processes. The mechanics done in a separate tool, again, electrical engineering and the automation. And this was done in a kind of a serial mode. Before one thing was not done, the next thing cannot start. And this today's situation where time to market is important and time to market is cost reduction and also your competitiveness in the market, this is not anymore state of the art. What we have to do is we have to optimize this. And this is the today's situation where we are in. We are trying already to start things in parallel and to serialize things. But we are reaching today the optimization upper level with individual tools. We cannot go one step further. So what have to be done next? We have to come to an integrated engineering who's really able to understand and manage all the status, even the different formats, in one integrated automation system or engineering system, to give a kind of a parallel approach. Because things can start in parallel. And this is not really theoretically. We are also trying to have some studies, and we are working on this. And this could look like this. This is a real example, a live example out of Europe for a discontinuous production process. The concept phase, okay, fine, the concept phase, we have not understood any changes in this point from the timeline. But already in the basic engineering, due to that data out of the concept were available, the basic engineering was 1 week faster. The detail engineering itself, because let me say all the instruments, all the motors, pump valve, everything was already there in this database. The detail engineering was by 5 weeks faster, just using an integrated engineering approach. In the installation, we have started 2 weeks earlier and we finished 3 weeks faster. So commissioning itself, because this is very important, especially in the process industry, we have not seen any advantage at this point of time. But out of a total investment of 40 million euro in a complete greenfield plan, we were able to reduce the project runtime by 11 weeks, 12.5% of the total runtime, and we were able to reduce the cost by 430 man-weeks, which was 19% of the total cost planned for this project. And everything what we have done at this point of time is only that we have not accepted this data are generated a second time and placed a second time somewhere else in the system. We have kept the data consistency at this point of time so that everybody is working only with the same data. Yeah, which advantages offer such integrated architectures from our point of view? If you look today from the field level up to the enterprise level, we are addressing here really control, operator, management level. The plant automation should cover the engineering, the interfaces, modularity, scalability, integrated diagnostic, interfaces to the ERP, and the accumulation of redundant storages. It is very important, if you look today at the amount of data which you are generating in your plants, and if you think how often this data are stored double in certain places, you have a problem to see which data is really the latest version. And on the other hand, with all your backup systems, you really have a lot of cost also, which you have to cover and to address. So what we would like to see here, and we would like to give some food for thought, is what can be the future of this? Let me talk about scalability at this point of time. When you're starting engineering a plant from day one, and you're talking, for example, about a DCS system, then you have to think about what are your future growth, what is the future extension which you might planning to design already the architecture. You have, at this point of time, also the discussion which you have to think, what about your spare part stock? How many different devices you would like to have? Just think about if the controller is also becoming a kind of a universal item, and the power of the controller itself is only changed due to the software license or the know-how you're giving inside this controller. Main automation vendor, main electrical vendor. Also, this is an important point, how to optimize the whole project runtime, how to organize and save cost. I mean, everybody of you may know how to build a house. If you are building privately a house or you're working on such a project, you have one guy who is taking care for the bricks, the other for the roof, the other for the electricity, and so on. If you have to coordinate all the things, you will spend a lot of time here. And this is a point where also hidden costs are coming up, and you have a lot of finger pointing definitely inside this project because everybody is not responsible for the delays in this project. So more and more important becomes also a common project management over all packages of such a project. The installation, the engineering, the commissioning phase out of one hand, and the complete life cycle services at the end of the day. And here, and we are still going in the cycle for the integrated engineering, for all these phases also a common data platform, a common engineering could help to reduce risks in projects, minimize delays and cost. What is the outlook in the future, what we are seeing, what will come, what will go? If we are just looking back to the 90s, everything was separate, and this is a situation we are mainly in today still. You have an independent automation control system, you have an independent plant engineering, an independent MES layer, and an independent PLM. All these things will grow together. The vision which we see, the future which we see is definitely that everything is going together on we call it digital enterprise platform, that everything will go together because it makes no sense of having same information in different places. Moreover, it is important to have everything as a kind of one object, and this object might have different views. If you're looking to a motor in a plant, this motor have, of course, a mechanical view. This motor, of course, have an electrical view. But this motor, of course, has also, from the engineering point, a view. So all these things from our side, from our point of view, will grow together. And as the Gartner said at this point, 2009, that this is a long-term investment, and this long-term investment have to be grown or driven as the ERP investments or transaction processes was done in the past. Yeah, one way towards the digital enterprise. Just looking to today, the product engineering and the production engineering, this is something where we are in today. And this is what we are doing. And of course, yes, the best-in-class products is required and will do the job. But this has its own limitations. And the productivity and the competitiveness, there is a limitation at this point, at some point of time. And here we see that the future goes in shared product and production life cycle. We are starting with first-time users, with first-time integrations, and yes, we are today not there where we should be and where we will be in the future. The key for really productivity and the key for competitiveness lies in universal integration of all and minimizing interfaces. Use your data only at one point of time. Let me give some real examples out of the life. Going from the engineering to the operation, the optimization, and to maintenance. Let us think about energy optimization. I think many of you know energy optimization is driven pretty much through people who are going through the plant, understanding the installed base, understanding, for example, the motors who are installed on the plant, the energy consumptions, and they have pretty good ideas that these motors are not anymore state-of-the-art, that you have to change the drive-based systems, and so on and so forth. But this cannot bring really an energy efficiency. This brings down the cost and brings down the energy consumption for sure. But real energy optimization can happen if you're understanding the process and you start optimizing the processes. And many chemical processes or pharma processes, we have to ask ourselves, is it required that the material is heated and cooled so often? If it's required that we have to heat to such level, or is the same reaction maybe happen already on a lower level? So real energy optimization will only happen if we are looking to the complete process and the complete installed base. Advanced process control. It was mentioned before in the last speech. I have seen this. This is also a very important thing which we feel and which we see. Give an example. There's a very important cricket match in India, yeah? And there's a break in this match. So many people across India in this moment will go to the washroom. What has happened? The water consumption suddenly have a peak. What has happened? Many pumps in the water distribution network will start operating. What will happen? The energy suppliers suddenly have a peak in energy consumptions. So this is a small example what can happen to give a kind of a peak pattern into an operation. So bringing this back to the process plant, what if systems are able to learn? What is if systems are able to understand pattern and understand if really such a peak comes that this is only of a very short duration? And what if the system starts reacting intelligent? This is what we understand under advanced process control, and this is something where really a lot of thought is going inside how to understand such pattern, how to realize such pattern, and how to optimize such pattern. Because nobody is really helped if suddenly all the power plants running on full capacity due to that there was a 3 minutes break in a cricket match. Advanced graphics interfaces is also a topic. I have seen it also before in the presentation. Today the automation is getting more and more complex, and the amount of data which have to be seen and worked on from the operator is getting more and more. This is also not anymore really state of the art, because we have to look what are really the key KPIs of this plant which are important to drive the whole plant. So what we see is really, we have to change the kind of the view on the plant. It is not anymore the PNIDs, which is with some variables and some text and information. What we see is really to have a kind of an advanced user graphic which gives only the key KPIs, on one hand, to drive the operation, and if something is going wrong or have to be operated, the system can jump directly from there to the right screen. On the other side, also, we have to have a kind of an effective alarm management. Whatever can happen in a huge plant, and if I'm looking to a power plant with more than 40,000 I/O points, if there's something going wrong, it will not come a single message up, you will have suddenly hundreds of messages. How an operator is really working on this overload of messages. So an effective alarm management who gives right in time the right message and is selecting up front which are the important messages shown on the top and which are the less important topics which have to be shown on the back. This is something which really optimizes the plant and increases the operator performance dramatically. We don't want to overload. Asset management. We are talked about a lot of data, and I started that we are collecting data already in the plant engineering phase. We collected data during the detail engineering. We collected data during the commissioning and also during the operation of the plant. So what if we are able, out of this whole data which we are collecting since the first investment start of the plant, if we are taking also decisions out of it? An example here, again, a pump inside your plant. This pump has a certain energy consumption pattern, and this is known after a time. And if we know what are the consumption which is allowed and which is the standard consumptions over the day with some peaks and lows, the system can recognize if there are upcoming energy changes. Maybe there's a problem with the gearbox, maybe there's a problem with the motor, with the drive, or with the liquids inside. So what if we are really able to have a kind of a plant maintenance based on real data out of your plant? That the system is giving a hint that, oh look, this pump will fail after a certain time because we can recognize already today that the energy consumption and the way the energy is consumed of this pump is changing. This can improve the preventive maintenance, this can definitely improve the failures in the plant, and this can increase definitely the lifetime of your investment. We call it online performance monitoring and asset management. Yeah, information. We are talking about a lot of information and data and storages on the same place. Let me give some examples what does it really mean. Looking to the today's situation, and the way we are using today different tools. We have people, for example, who are working on a design of panels and hardware. And these people, of course, because they are designing the panels, using all the devices which are inside the panel. And we have another colleague who sits maybe in the next room, who's working on the control system. And this colleague, for whatever reason, is deciding that he has to change the hardware which is required. What is in the today world? They may be talking to each other, sending an email, or they not even care. At the end of the day, maybe the colleague who have done the control system will find the wrong hardware inside the panel, or maybe the guy who's making the hardware design will later on recognize that the power consumption which he have assumed is not working because these things which are now in the panel are not the things which he have designed. What if we really can work with an object-oriented system where we have this item only once on a single database and everybody is working on the single database and can engineer based on a single object? In this case, if the software engineer changes the device, the hardware engineer is getting notified and he can decide or he can even talk based on this information. And this is only a small example of collaborative engineering, which definitely help to shorten the engineering cycles, which definitely help to significantly lower the project costing, faster time to market, and what is also from my point of view very important, the errors, the failures which you have during the engineering is going drastically down. Now, we have a lot of data, and we know exactly how our plant look like. The next level could be that out of all these data, we are generating a kind of a 3D model of our plant. This 3D model is exactly the copy of the data which we have collected in the whole engineering phase. And why this makes sense? This can make sense, for example, for unmanned platforms. So if somebody from the maintenance crew have to go there, he knows exactly where to go and how to go. This can help to see already also if you get directly the online data into the 3D model. But more important, this could help of training the operators. Operator training is a very important point which we see because the simulation and the trainer operation in more and more complex system, and just think about chemical plants, it is important that the users know and the operators know how to handle critical situations. And this, in best case, they should never try on the real plant in a real process. This they should try upfront. Looking in the today world, I mean, no pilot is entering an airplane before he was certain hours in a simulator. So why not, especially for critical processes, for really critical situations, test the same upfront in such simulations? The data are available because if we really talk about an integrated engineering, the data are from day one inside the same database. Yeah, coming to the end, I mean, the situation which we have yesterday was a kind of a local automation technology. So we had single islands in the plant who have not really exchanged data. Today, we have, with all pros and cons and maybe challenges inside, a communication-aided communication automation. It means the islands from earlier time are talking to each other, exchanging data, and based on this, it can work. The tomorrow world, which we see, is the optimization of the entire production process with innovative software systems. And the basis to this is that we are coming to a common platform, a common engineering, where even collaboration with different vendors, with different suppliers is easily possible. This is an important step for the future, and the future where we have self-optimization system, where system can react on critical situations on their own, and where we can analyze based on virtual models other options of plant operation. With this, I thank you very much